Hello, pre-calculus or trigonometry students, and welcome to the continuing lesson on identities of sums and differences. And in this video, we are going to prove the identity for the tangent of a sum. We talked about tangent of cosine of a sum, sine of a sum, cosine of a difference, sine of a difference. And so it's only natural that now we talk about tangent. And this is a bit of a messy identity here, but just to recap, the main idea is that you have an expression inside here, inside the trig function, that's a little bit complicated. The identity allows you to separate into individual inputs here, where you only have one value or one variable here, but the trade-off for that is the expression looks a little bit more complicated. So to do this proof, since I don't really know how to handle this yet, I don't know what to do with tangent yet, I'm just going to convert to sine and cosine. Okay. So this is going to become sine of A plus B over cosine of A plus B. And then I'm going to apply sine of sum on the numerator, and then cosine of a sum on the denominator. So for the sine of a sum function, I'm going to get sine A cos B plus cos B plus cos A sine B. For the cosine, I'm going to get cos A cos B, minus sine A sine B. And here comes like the very tricky and messy part, but the nice thing about this messy part is that it'll help you to reduce things very, very quickly. So now I have this expression here, and notice here we've been successful at separating these. We separated A and B, and now we just need to turn all of these sine and cosines into tangents. And so it's very hard to see this, and if you don't see this right away, don't worry. It takes a lot of practice and a lot of failures in order to actually be able to get to this point. And I've tried this and I've messed up a few times, but I've been able to realize that I need to get this sine A to turn into tangent, and I need to get cosine B to go away completely. And so the only way to do that is to multiply by 1 over cos A cos B. And whatever I multiply on the top, I'm going to have to do the same thing on the bottom. Okay? And really getting this expression right here, more or less, is the main and the entire work of this problem. Okay, the rest of this is just doing some bit of cleanup here. So when I get to this point, I'm just going to distribute this entire term here over to these sides. Okay. So now I get sine A cos B divided by cos A cos B plus cos A cos B, cos A sine B divided by cos A cos B. That takes care of the top of the fraction. Now for the bottom, I get cos A cos B over cos A cos B plus, or minus rather, sine A sine B over cos A cos B. And now this part actually gets kind of nice. You can see that a lot of this stuff is going to cancel. So in other words, I get cos B right here. That's going to go away because that's just going to give me a 1. And then I have cos A on this side, so that's going to go away as well. That's just going to give me a 1. On the bottom here, I have cos A, cos A, cos B, cos B. So all of this goes away, and I'm going to write a 1 here just so I don't forget. And so now what you see here is on the top, I have sine A cos A, okay, sine A over cos A on this part right here. So sine A over cos A is just tangent of A. So this part right here becomes tangent of A. Then I have sine B cos B, well that's just tangent of B. On the bottom I get 1 minus, and same thing here, sine A cos A, so that's tan A. Sine B cos B, that's tan B. And that completes the proof because this expression right here is the same thing as the right-hand side. Let me be a little bit more clear. I don't want to get slop here. This is the left-hand side that we're starting with at the top. Okay? And when we finish, we get the right-hand side. So the proof is complete. And once again, you can see that the trickiest part is this part right here where you have to multiply by cos A cos B and cos A cos B down here. If you get to this point, the rest of it is just simplifying. And I can't say this enough. It's just to do these proofs, you have to be willing to try some things. You have to make a guess, but an educated guess, and you have to be prepared that your guess doesn't work, and you have to be patient and willing to accept the fact that it might take you a couple of tries to do this. Now you can always ask your teacher. You can always ask me, and I will be glad to explain this to you. But I think the best way to learn is to struggle with this, to hit a dead end a few times, and then make a breakthrough. And I think that's the most effective way for you to prepare for anything, to make sure that you really know it, is to try, fail better, and then eventually find success. So this material is definitely challenging. It is but it is still certainly within your capabilities if you are willing to work hard enough at it. As always, ask your teacher for help if you do not understand. Have a wonderful day.